In this video, we will show you how to diagnose connectivity problems on a fiber link and verify proper installation of new fiber cables using the PingerPro Plus Fiber Model 75 and a fiber test kit from Cyber Data Systems. Connectivity is the main source of problems for both copper and fiber cabling systems. Fiber cable testing consists of optical power loss measurements, which are also referred to as attenuation loss. There are many potential sources for attenuation loss in a fiber link. Each component in the link has an associated insertion loss, even when installed perfectly. As more components are added to the link, the total attenuation loss budget is reduced, making proper installation even more critical for the link to operate as expected. Fiber cable installations can have very large attenuation losses due to improperly installed connectors. A cracked, scratched, or beveled fiber face will cause light dispersion and reflection, which increases loss. Misalignment between mated pairs of fibers or using fiber link components with different core sizes can significantly reduce the optical power transmitted. Attenuation loss increases when fiber cables are damaged due to overstressing, crushing, or tight bending. Another major source of attenuation loss is contaminated fiber interfaces at a connection point. Unprotected fibers in connectors, adapters, and SFP or GBIC modules can easily collect foreign materials, and any residue left on the fiber mating surface during connector installation adds loss to the link. Rigorous cleaning of all surfaces is essential, and fibers should be capped until put in use. Any single issue or a combination of these issues can cause enough attenuation loss for the link to perform poorly or fail. We will first go through the troubleshooting process for a fiber link that has been properly installed and is operational and now has failed. The IT specialist is tasked with identifying the cause of the problem and performing the appropriate corrective action. The PingerPro Model 75 and a fiber test kit provide the tools that the technician will need to conduct both active and passive fiber tests to quickly pinpoint the problem. Start by disconnecting the fiber cable at the connection port at one end of the link. Use the fiber patch cord and connect the PingerPro to the device port. Verify that a link is established and measure the optical power transmitted by the port. The measured level should be compared with the manufacturer's specification for the SFP or GBIC module. The PingerPro multi-mode and single-mode SFPs have a typical power output of -6 dBm. While connected to the port, conduct a quick ping test to a server or another network device to determine if there are potential configuration or traffic loading problems beyond the link under test. There could be other network issues that are causing or contributing to the problem. In this case, the PingerPro transmitted 100 pings with no packet loss, and round trip times were less than a second, meaning that traffic levels were low. Next, connect the PingerPro to the disconnected fiber and measure the optical power transmitted by the far end. The level should be about the same as the near end minus the loss of the fiber link. Fiber link loss should be relatively small unless it is a very long link or has many connections. In our case, there is about 11.1 dB loss, which is excessive and indicates that there is a problem between this point and the far end. Disconnect the PingerPro from the fiber and replace it with an adapter and a loopback device. Go to the far end link connection port and connect the PingerPro to the device port. Verify that a link is established and measure the optical power, which should be close to the same level as the other end. In this example, the measured level is -7.5 dBm, which is close to the level at the other end. We now know that the fiber link must be the cause of the large attenuation loss, and we can make a dark fiber measurement on the link by attaching the PingerPro to the disconnected fiber and measuring the transmitted and received power that is sent out and looped back. In this case, we see 11.1 dB difference and have verified that there is a problem in the link. Cleaning and reseating the connection points or installing a new fiber cable may be required to solve the loss problem. The next example shows how to use the PingerPro and the fiber test kit to verify the installation of new fiber cables. To run a fiber test on a passive or dark cable, it is important to set a reference to determine a baseline measurement of the amount of light being injected into the cable under test. A cable installer should use this procedure for setting a reference for better accuracy and consistency when verifying multiple cables. A network technician may just be interested in an approximate measurement for quick connectivity assessment and not take the extra time to establish a reference. There are different fiber test kits used for cable verification depending on the connector types to be tested. Cyber offers standard LC and SC type fiber kits with other adapters available. Note that when running a passive test on multi-mode fibers, a mandrel must be placed on the transmit fiber of the patch cable connected to the PingerPro. Using a mandrel improves the accuracy of the measurement. In a multi-mode link, outer and inner modes of light are present in the fiber core. The mandrel allows for the outer modes to be eliminated, which better simulates an installed link environment. To set a reference for testing fiber cables with LC connectors, follow the setup as seen in diagram A1. To set a reference for testing fiber cables with SC connectors, follow the setup as seen in diagram B1. Run the fiber test and note the received value measured. This is the baseline measurement for the amount of light that will be injected into the cable under test. A measurement of two-way link loss can be calculated by subtracting this received value from the value measured when the fiber test is run on the dark cable. To measure the amount of light being injected into the cable under test, follow the setup as shown in diagram A2 for LC connected fibers or diagram B2 for SC connected fibers. Run the fiber test and again note the received value measured. Subtract the reference value from this value to determine the loss experienced by the fiber cable. TIA standards dictate what is an acceptable amount of loss that fiber cables should experience. If the losses in the cable is below the threshold set by the TIA, then you can conclude that the cable is operating correctly. If the losses in the cable is above the threshold, this indicates that the cable may have become damaged or was incorrectly terminated. Before using the PingerPro plus fiber to run any fiber test, it is important to clean all of the connectors on the fiber cables, as well as any adapters that may be involved in the link. The fiber test kit includes a one-click fiber cleaner, as well as cotton cleaning swabs to allow this to be done. With the PingerPro Model 75 and a fiber test kit from Cyber Data Systems, you will be able to diagnose connectivity issues and verify new fiber cable installations that are critical to maintaining network performance.